All right. So we are talking about precipitation reactions today. And what we see, whoops, and we talked about this a little bit in class, probably, is that a precipitate is a solid produced in a chemical reaction between two solutions. So really what this looks like is you have solution 1, which is AQ, plus solution 2, which is also AQ. And then what you get at the end is a solid on the bottom and a solution. So you have this solid and a solution. So in terms of how we categorize this, precipitation, a precipitation reaction, in terms of what we've already talked about, is a double exchange reaction in which two dissolved ions, and that's one cation, one anion, come together to form a solid. Now, what we've talked about before with, and these are ionic compounds. It's an ionic compound. Now, what we talked about before was that all ionic compounds are soluble in water because the ions dissociate. Well, it turns out for many of them that's true, but there are some whose interparticle attraction, the electrostatic attraction, is so strong that the water molecules can't actually break apart the ions, so they've come together. So one example from what you guys saw in the lab was this, where you have a solution of copper nitrate, a solution of sodium hydroxide, come together and make a solution of sodium nitrate plus copper hydroxide. And this is a solid. So this is our precipitate, is the copper hydroxide. Now, here's another example right here. We have calcium chloride and sodium oxalate. This is the kidney stone. So what we know is mixing two solutions sometimes, this is an emphasis on sometimes, forms a precipitate. And the degree to which a compound dissolves is called its solubility. So different compounds are more or less soluble in water. We think of table salt as being will totally dissolve in water, and that's true. But if you keep adding tons and tons and tons of table salt, eventually the water will get saturated, and saturated is a word we've used before, we've heard before, where the solution can contain no more solute, no more solid will go in. Now, it turns out every substance has its own solubility in water. Some, like calcium oxalate, have a very low solubility, like wicked low. So not much will dissolve. So if you put solutions of calcium chloride and sodium oxalate together, the calcium and the oxalate will bond and will form a solid because it has such low solubility. Now, the solubility can vary, and don't write this in. Don't write this in because this is on the back of something like this is on the back of your periodic table. So you can tell if a solid is going to form when mixing solutions by looking at this table. And this table we will talk about in class. The confusing part is S. So when we talk about it, S equals soluble. It does not equal solid. So S means that it will dissolve. N means it will not dissolve. So N means if you put, for example, if you put a solution with calcium together with a solution of hydroxide, you come here and you say, oh, a solid is formed. Now, if I have, let's do a blue one. Oh. Blue, come on. All right, so let's say I mix solutions of sodium chloride and, I don't know, zinc nitrate. So we switch partners. And how we test to see if a precipitate forms by switching partners. So this is the plus, this is the minus, this is the plus, this is the minus. So we put Na and NO3 and Zn and Cl together. Now, what you'll see is that Na and NO3 are always soluble. All right, so we have Na, NO3 come together. Oh, no precipitate. And now let's check zinc and Cl. Well, we have zinc and Cl. That should be a lowercase l. That's bad. So no. So if I mix those two solutions together, I get no solid. It's just, it'll look the same at the beginning as it does at the end. So we'll use this chart to figure out if a solid forms. Then last little bit of notes. There are positive and negative aspects to the solubility of substances. No, let's stay black. Aspects, let's see, to the solubility of substances. Now, we can, and by this I mean like if you ingest something that might be blocking somewhere along the line, you might be able to dissolve it by having a certain reaction. But the negative aspect is something like the kidney stones. So, and once the substance is absorbed into the body, it could be hard to remove through the kidneys or liver. Kidneys, liver, which are our body's natural filtration mechanisms. So things like kidney stones, once the substance is absorbed, so you have that the calcium oxalate, if that solidifies in your body, well then you're in trouble and you get the kidney stones. But if you had other things throughout which had reacted with it, you'd be fine to make it not occur. So what substances precipitate? It depends on solubility. And compounds that are not very soluble tend to form precipitates. Mixing two solutions often results in the formation of a precipitate, sometimes doesn't, and soluble substances can interact with the human body in either positive or negative ways. So for another solubility issue. So solubility is a big issue with drugs that we take. So like a lot of, say, cancer drugs or drugs that treat different diseases are not very soluble. So there's a lot of money that can be made in trying to figure out how to make them more soluble so they actually go into your body in a effective and therapeutic way.